Halo? Halo, kok suaranya anu menggema?
Who is this?
Suara ya lu. Suaranya anu menggema.
Halo Pak.
Halo?
Pak.
Halo, Arif.
Ya Pak Asbi.
Oh iya. Nah, tadi kok apa? Putus-putus.
Ya biasa Pak, lagi cari koneksi WiFi.
Oh. Oke.
Oke,
Tapi ini
sudah ready semua kok, tinggal mulai 3:30 mulai.
iya. Berarti live YouTube-nya mulai dari sekarang. Sudah itu.
Sudah. Bu Parti lo malah nih YouTube.
Iya. Jadi saya juga join YouTube.
Aman Pak.
Aman.
Ini juga yang digunakan oleh untuk
Ini masih anu ya, yang di matematik ya?
Iya Pak, masih Pak. Untung beda jalur Pak. Udah beda jalur udah bisa Pak. Dari
Ya,
tadi
ya.
estafet Pak.
Kenapa?
Dari tadi estafet. Dari
Oh,
pagi. Jadi yang pagi
dari
belum
pagi.
itu belum selesai. Lah ya pagi belum
Nyambung
selesai.
lagi.
Tapi yang satunya itu sudah mulai. Ya kayak gini loh Pak.
Ini masih anu ya, yang di
lihat sini ya.
Ya ini matematik, tadi pagi fakultas.
Iya.
jalur udah bisa lah.
future time. Ini di previous time, ini kita ketahui. Katakanlah Anda mulai dari initial time. Ya. Kalau Anda posisi initial time, ini ketahui.
Halo Pak
Halo,
Mukit.
Pak Mukit.
Pak Mukit.
Halo, 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 halo. Assalamualaikum.
Waalaikumsalam.
Mungkin kita bisa menggunakan apa yang disebut sebagai central polynomial.
Nah, on cam Pak.
Neng
Kampus,
kampus,
Pak. Kampus, Pak.
Ya.
Oh.
Idenya kok biru Pak.
Ah. Eh,
Kalau Anda mulai Bapak menghitung solusi pada dimulai dari initial time. Untuk initial time, T sama dengan 0, so di sini 0, ini juga 0. So setiap U of 0 kita pilih. Yang jadi masalah sekarang adalah Anda ingin menentukan U of delta T, jadi future time. Untuk menentukan future time, Anda memerlukan solusi sebelum initial condition.
Mas Oki,
Gimana Pak?
ini langsung dihosi sendiri.
Nanti tak lempar ke Fatihah Pak.
Nanti, oh ya wes.
Ini udah tak jadiin co-host Pak.
Ya, enggak maksudnya tak kirain meh dijagani dhewe no.
Udah Pak. Isih melu saya. Habis ini kabur aku.
Ya.
pula dari program studi matematika yang didirikan pada tahun 1969. Fakultas Matematika dan Ilmu Pengetahuan Alam disetujui menjadi salah satu fakultas di Undip pada tanggal 21 Oktober 1993. Selanjutnya, berdasarkan SK Rektor Universitas Diponegoro tahun 2012, berubah nama menjadi Fakultas Sains dan Matematika.
Salah satu misi Fakultas Sains dan Matematika adalah menyiapkan lulusan yang memiliki kemampuan di bidang matematika, sains dasar dan terapannya yang unggul, bermoral, beretika, berwawasan kebangsaan untuk menghasilkan lulusan yang kompetitif di tingkat nasional maupun internasional. Fakultas Sains dan Matematika sangat berpotensi untuk ditingkatkan kualitasnya dalam rangka mendukung Undip menjadi universitas riset. Riset unggulan yang bersifat kolaboratif, multidisipliner, sampai dengan hilirisasi riset, yaitu sampai ke komersialisasi hasil riset, terus dikembangkan, seperti teknologi plasma, teknologi nano, dan keramba jaring apung bertingkat. Hasil-hasil riset ini tentu memberikan kontribusi nyata dalam mencapai kriteria kinerja Undip sebagai perguruan tinggi negeri berbadan hukum. Selain itu, dari hasil-hasil riset ini dapat dikembangkan teaching industri. Diharapkan mahasiswa menjadi lebih berkualitas, baik dari segi kognitif, psikomotorik, maupun afektif. Fakultas Sains dan Matematika melakukan kerjasama dengan berbagai institusi, baik tingkat nasional maupun internasional. Salah satunya adalah kerjasama riset dengan Badan Penelitian dan Pengembangan Perhubungan, Perusahaan Umum Damri, mengenai penelitian dan pengembangan penggunaan aplikasi teknologi alat rekam jejak kendaraan bermotor umum dalam rangka peningkatan keselamatan lalu lintas dan angkutan jalan, khususnya G3.
Bidang akademik dan kemahasiswaan menyiapkan mahasiswa untuk menjadi lulusan yang berkompeten di bidang sains dan matematika, menguasai teknologi, dan komplit. Komunikator, profesional, leader, entrepreneur, thinker, dan edukator.
Bidang sumber daya ini berperan di dalam merencanakan pendanaan dan sarana prasarana serta sumber daya manusia di dalam rangka mendukung kinerja fakultas untuk mencapai indikator kinerja perguruan tinggi negeri berbadan hukum.
Bidang 3 mengembangkan komersialisasi hasil-hasil riset yang unggul, mengelola dan mengembangkan pemanfaatan teknologi informasi, serta sinergi dengan alumni agar mampu bersaing di tingkat nasional dan internasional.
Riset dan inovasi merupakan komponen penting dalam mendukung upaya Universitas Diponegoro menuju universitas riset yang unggul. FSM, Fakultas Sains dan Matematika, komit terhadap riset dan inovasi. Hingga saat ini, capaian FSM dalam riset dan inovasi menduduki peringkat pertama dalam perolehan kompetitif grade tingkat nasional di lingkungan Universitas Diponegoro, yang menghilirkan hasil-hasil riset inovatif ini ke arah produk-produk komersial yang inovatif.
Fakultas Sains dan Matematika mempunyai 11 program studi. Program studi sarjana dan magister matematika. Program studi sarjana dan magister biologi. Program studi sarjana dan magister kimia. Program studi sarjana dan magister fisika. Program studi D3 instrumentasi dan elektronika. Program studi sarjana statistika. Program studi sarjana ilmu komputer atau informatika. Selain dalam kegiatan akademis, mahasiswa Fakultas Sains dan Matematika juga aktif mengikuti kegiatan non-akademis.
Salah satu misi Fakultas Sains dan Matematika adalah menyiapkan lulusan yang memiliki kemampuan di bidang matematika, sains dasar dan terapannya yang unggul, bermoral, beretika, berwawasan kebangsaan untuk menghasilkan lulusan yang kompetitif di tingkat nasional maupun internasional. Fakultas Sains dan Matematika sangat berpotensi untuk ditingkatkan kualitasnya dalam rangka mendukung Undip menjadi universitas riset. Riset unggulan yang bersifat kolaboratif, multidisipliner, sampai dengan hilirisasi riset, yaitu sampai ke komersialisasi hasil riset, terus dikembangkan, seperti teknologi plasma, teknologi nano, dan gerambe jaring apung bertingkat. Hasil-hasil riset ini tentu memberikan kontribusi nyata dalam Selain itu, dari hasil-hasil riset ini dapat dikembangkan teaching industri. Diharapkan mahasiswa menjadi lebih berkualitas, baik dari segi kognitif, psikomotorik, maupun afektif. Fakultas Sains dan Matematika melakukan kerjasama dengan berbagai institusi, baik tingkat nasional maupun internasional. Salah satunya adalah kerjasama riset dengan Badan Penelitian dan Pengembangan Perhubungan, Perusahaan Umum Damri, mengenai penelitian dan pengembangan penggunaan aplikasi teknologi alat rekam jejak kendaraan bermotor umum dalam rangka peningkatan keselamatan lalu lintas dan angkutan jalan, khususnya P3.
Bidang akademik dan kemahasiswaan menyiapkan mahasiswa untuk menjadi lulusan yang berkompeten di bidang sains dan matematika, menguasai teknologi, dan komplit. Komunikator, profesional, leader, entrepreneur, thinker, dan edukator.
Bidang sumber daya ini berperan di dalam merencanakan pendanaan dan sarana prasarana serta sumber daya manusia di dalam rangka mendukung kinerja fakultas untuk mencapai indikator kinerja perguruan tinggi negeri berbadan hukum.
Bidang 3 mengembangkan komersialisasi hasil-hasil riset yang unggul, mengelola dan mengembangkan pemanfaatan teknologi informasi, serta sinergi dengan alumni agar mampu bersaing di tingkat nasional dan internasional.
Riset dan inovasi merupakan komponen penting dalam mendukung upaya Universitas Diponegoro menuju universitas riset yang unggul. FSM, Fakultas Sains dan Matematika, komit terhadap riset dan inovasi. Hingga saat ini, capaian FSM dalam riset dan inovasi menduduki peringkat pertama dalam perolehan kompetitif grant tingkat nasional di lingkungan Universitas Diponegoro, yang menghilirkan hasil-hasil riset inovatif ini ke arah produk-produk komersial yang inovatif.
Fakultas Sains dan Matematika mempunyai 11 program studi. Program studi sarjana dan magister matematika. Program studi sarjana dan magister biologi. Sarjana dan magister kimia. Program studi sarjana dan magister fisika. Program studi D3 instrumentasi dan elektronika. Program studi sarjana statistika. Program Studi Sarjana Ilmu Komputer atau Informatika. Selain dalam kegiatan akademis, mahasiswa Fakultas Sains dan Matematika juga aktif mengikuti kegiatan non-akademis.
Salah satu misi Fakultas Sains dan Matematika adalah menyiapkan lulusan yang memiliki kemampuan di bidang matematika, sains dasar dan terapannya yang unggul, bermoral, beretika, berwawasan kebangsaan untuk menghasilkan lulusan yang kompetitif di tingkat nasional maupun internasional. Fakultas Sains dan Matematika sangat berpotensi untuk ditingkatkan kualitasnya dalam rangka mendukung Undip menjadi universitas riset. Riset unggulan yang bersifat kolaboratif, multidisipliner, sampai dengan hilirisasi riset, yaitu sampai ke komersialisasi hasil riset, terus dikembangkan, seperti teknologi plasma, teknologi nano, dan geramba jaring apung bertingkat. Hasil-hasil riset ini tentu memberikan kontribusi nyata dalam mencapai kriteria kinerja Undip sebagai perguruan tinggi negeri berbadan hukum. Selain itu, dari hasil-hasil riset ini dapat dikembangkan teaching industri. Diharapkan mahasiswa menjadi lebih berkualitas, baik dari segi kognitif, psikomotorik, maupun afektif. Fakultas Sains dan Matematika melakukan kerjasama dengan berbagai institusi, baik tingkat nasional maupun internasional. Salah satunya adalah kerjasama riset dengan Badan Penelitian dan Pengembangan Perhubungan, Perusahaan Umum dan RI, mengenai penelitian dan pengembangan penggunaan aplikasi teknologi alat rekam jejak kendaraan bermotor umum dalam rangka peningkatan keselamatan lalu lintas dan angkutan jalan, khususnya G3.
Bidang akademik dan kemahasiswaan menyiapkan mahasiswa untuk menjadi lulusan yang berkompeten di bidang sains dan matematika, menguasai teknologi, dan komplit. Komunikator, profesional, leader, entrepreneur, thinker, dan edukator.
Bidang sumber daya ini berperan di dalam merencanakan pendanaan dan sarana prasarana serta sumber daya manusia di dalam rangka mendukung kinerja fakultas untuk mencapai indikator kinerja perguruan tinggi negeri berbadan hukum.
Bidang 3 mengembangkan komersialisasi hasil-hasil riset yang unggul, mengelola dan mengembangkan pemanfaatan teknologi informasi, serta sinergi dengan alumni agar mampu bersaing di tingkat nasional dan internasional.
Riset dan inovasi merupakan komponen penting dalam mendukung upaya Universitas Diponegoro menuju Universitas Riset yang unggul. FSM, Fakultas Sains dan Matematika, komit terhadap riset dan inovasi. Hingga saat ini, capaian FSM dalam riset dan inovasi menduduki peringkat pertama dalam perolehan kompetitif grant tingkat nasional di lingkungan Universitas Diponegoro, yang menghilirkan hasil-hasil riset inovatif ini ke arah produk-produk komersial yang inovatif.
Fakultas Sains dan Matematika mempunyai 11 program studi. Program studi sarjana dan magister matematika. Program studi sarjana dan magister biologi. Program studi sarjana dan magister kimia. Program studi sarjana dan magister fisika. Program studi D3 instrumentasi dan elektronika. Program studi sarjana statistika. Program studi sarjana ilmu komputer atau informatika. Selain dalam kegiatan akademis, mahasiswa Fakultas Sains dan Matematika juga aktif mengikuti kegiatan non-akademis. Dari program studi matematika yang didirikan pada tahun 1969. Fakultas Matematika dan Ilmu Pengetahuan Alam disetujui menjadi salah satu fakultas di Undip pada tanggal 21 Oktober 1993. Selanjutnya, berdasarkan SK Rektor Universitas Diponegoro tahun 2012, berubah nama menjadi Fakultas Sains dan Matematika.
Salah satu misi Fakultas Sains dan Matematika adalah menyiapkan lulusan yang memiliki kemampuan di bidang matematika, sains dasar dan terapannya yang unggul, bermoral, beretika, berwawasan kebangsaan untuk menghasilkan lulusan yang kompetitif di tingkat nasional maupun internasional. Fakultas Sains dan Matematika sangat berpotensi untuk ditingkatkan kualitasnya dalam rangka mendukung Undip menjadi Universitas Riset. Riset unggulan yang bersifat kolaboratif, multidisipliner, sampai dengan hilirisasi riset, yaitu sampai ke komersialisasi hasil riset, terus dikembangkan, seperti teknologi plasma, teknologi nano, dan gerambe jaring apung bertingkat. Hasil-hasil riset ini tentu memberikan kontribusi nyata dalam mencapai kriteria kinerja Undip sebagai perguruan tinggi negeri berbadan hukum. Selain itu, dari hasil-hasil riset ini dapat dikembangkan teaching industri. Diharapkan mahasiswa menjadi lebih berkualitas, baik dari segi kognitif, psikomotorik, maupun afektif. Fakultas Sains dan Matematika melakukan kerjasama dengan berbagai institusi, baik tingkat nasional maupun internasional. Salah satunya adalah kerjasama riset dengan Badan Penelitian dan Pengembangan Perhubungan, Perusahaan Umum dan BRI mengenai penelitian dan pengembangan penggunaan aplikasi teknologi alat rekam jejak kendaraan bermotor umum dalam rangka peningkatan keselamatan lalu lintas dan angkutan jalan, khususnya G3.
Bidang akademik dan kemahasiswaan menyiapkan mahasiswa untuk menjadi lulusan yang berkompeten di bidang sains dan matematika, menguasai teknologi, dan komplit. Komunikator, profesional, leader, entrepreneur, thinker, dan edukator.
Bidang sumber daya ini berperan di dalam merencanakan pendanaan dan sarana prasarana serta sumber daya manusia di dalam rangka mendukung kinerja fakultas untuk mencapai indikator kinerja perguruan tinggi negeri berbadan hukum.
Bidang 3 mengembangkan komersialisasi hasil-hasil riset yang unggul, mengelola dan mengembangkan pemanfaatan teknologi informasi, serta sinergi dengan alumni agar mampu bersaing di tingkat nasional dan internasional.
Riset dan inovasi merupakan komponen penting dalam mendukung upaya Universitas Diponegoro menuju Universitas Riset yang unggul. FSM, Fakultas Sains dan Matematika, komit terhadap riset dan inovasi. Hingga saat ini, capaian FSM dalam riset dan inovasi menduduki peringkat pertama dalam perolehan kompetitif grade tingkat nasional di lingkungan Universitas Diponegoro, yang menghilirkan hasil-hasil riset inovatif ini ke arah produk-produk komersial yang inovatif.
Fakultas Sains dan Matematika mempunyai 11 program studi. Program studi sarjana dan magister matematika. Program studi sarjana dan magister biologi. Program studi sarjana dan magister kimia. studi sarjana dan magister fisika. Program studi D3 instrumentasi dan elektronika. Program studi sarjana statistika. Program studi sarjana ilmu komputer atau informatika. Selain dalam kegiatan akademis, mahasiswa Fakultas Sains dan Matematika juga aktif mengikuti kegiatan non-akademis. Dari program studi matematika yang didirikan pada tahun 1969. Fakultas Matematika dan Ilmu Pengetahuan Alam disetujui menjadi salah satu fakultas di Undip pada tanggal 21 Oktober 1993. Selanjutnya berdasarkan SK Rektor Universitas Diponegoro tahun 2012 berubah nama menjadi Fakultas Sains dan Matematika.
Salah satu misi Fakultas Sains dan Matematika adalah menyiapkan lulusan yang memiliki kemampuan di bidang matematika, sains dasar dan terapannya yang unggul, bermoral, beretika, berwawasan kebangsaan untuk menghasilkan lulusan yang kompetitif di tingkat nasional maupun internasional. Fakultas Sains dan Matematika sangat berpotensi untuk ditingkatkan kualitasnya dalam rangka mendukung menjadi universitas riset. Riset unggulan yang bersifat kolaboratif, multidisipliner, sampai dengan hilirisasi riset, yaitu sampai ke komersialisasi hasil.
afternoon, ladies and gentlemen. We would like to wait for a minute because due to technical meeting, due to the technical issues, we need to wait for a while. So please wait for a minute. And then for all participants who haven't used the virtual background, please use the virtual background attached in the chat box. Ms. Fatia already sent to the chat box and you may use for the virtual background. Okay, everyone could turn on the camera because in this webinar, we will have some photo session later. So we hope that you can participate in the photo session also. Okay, I saw already 143 participants join in this session. So many participants will attend this webinar. And hopefully this webinar can be more insightful to all participants who has joined today. Okay, for everyone who has done the active camera, please you may turn on the camera. Okay, well, I still see there are some of you who has still off camera. I would like to invite you to turn on your camera. Already 20 people just did the active camera, but the rest are still off camera. You may turn on the camera while we are waiting for the speaker. I would like to Okay. The speaker has already came into the room, and then we could start today's webinar. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and Okay. Good afternoon, ladies and gentlemen, and greetings to all of us. The Honorable Dean of Faculty of Science and Mathematics, Mrs. Professor Dr. Widyawati, SSI dan MSI, the Honorable Head of Department of Statistics, Faculty of Science and Mathematics, Mr. Dr. Tahunnya, MSI, so the Honorable Speaker, Mr. Dr. Arif Gusnanto, and then the Honorable Moderator, Mr. Dr. Budi Warsito, MSI, and the Honorable all lecturer and staff of Department of Statistics, and also the beloved webinar participants. Firstly, let's say thanks to God, Allah Subhanahu wa Ta'ala, who has been giving us His blessings and mercy so that we can gather in this virtual Zoom place meeting without something wrong happen. Ladies and gentlemen, I am Fadila Atansa, as the Master of Ceremony will guide this webinar today. But before starting our agenda, let me explain the agenda schedule of this webinar. First, session is opening, and then will be continued by opening speech by Dean of Faculty of Science of Mathematics. This is Professor Dr. Widyawati, SSI, MSI, and then we will have some photo session first for documentation, and then we'll be continued with our main event. It is Big Data Analytics in Practice webinar by Mr. Dr. Arif Gusnanto, and then the last is closing. All beloved participants, now I would like to invite Mrs. Professor Dr. Widyawati, SSI, MSI, to give her opening speech for today's webinar. For Mrs. Professor Dr. Widyawati, SSI, MSI, time and screen are welcome.
Okay, thank you very much for Master of Ceremony, Miss Fadila Atansya Tamardina. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Excellencies, Dr. Arif Gusnanto from Department of Statistics, Leeds University, United Kingdoms. Thank you very much, Dr. Arif Gusnanto, for your joining in this event, and welcome to the Diponegoro University, Indonesia. Hello, Dr. Arif. Honorable Dr. Tarno, as a head of Statistics Department, Faculty of Science and Mathematics, Diponegoro University. Dr. Tati Widihari, as a Secretary of Statistics Undergraduate Study Programs. Dr. Budi Warsito, as a Moderator. Dear lecturer at Department of Statistics and all participants. It is my great pleasure to cordially welcome you to the Department of Statistics Visiting Lecturer Events 2021. After careful consideration for health concerns surrounding the spread of coronavirus disease or COVID-19, this event was conducted virtually by using Zoom platforms. This event is one of the world-class university program which aim to increase collaboration with leading university in the world. First of all, let us
thank Allah Subhanahu wa Ta'ala, the most gracious and merciful God, because with His permission today, we can gather here to join together for online visiting Professor events. My sincere gratitude, especially to Dr. Arif Kusnanto, who will be today's speaker, and to all participants for their great contribution in promoting statistics, sciences, and technology for Diponegoro University Academia. In addition, for today's lecture, the topic of the material is Big Data Analytics in Practice. As mentioned in his CV, he has many interesting researches in these topics, such as in bioinformatics, health, industry, and other sectors. I hope this event can bring new insights into the application of big data analytics in various fields. Ladies and gentlemen, I want to use this opportunity to congratulate the head of statistics departments, lecturer, and all participants for their foresight in choosing the best lecturer and the topic that has a national relevance. As we know that the vision of the Faculty of Science and Mathematics, Diponegoro University, is become an excellent research faculty with international reputation in the field of statistics, science, and mathematics, and the development of its applications. This event strongly supports our mission to prepare students who have excellent skill in the field of statistics, especially on big data analytics in practice, and also to produce competitive graduates at the national and international levels. I hope these visiting lecturer events can inspire many scientists to improve their research and open broader international collaboration between Department of Statistics, Diponegoro University, and Leeds University. Last but not least, by the grace of God Almighty and consent of all participants, on behalf of Faculty of Science and Mathematics, Diponegoro University, I am as Dean hereby announce that online visiting lecturer events with the topics Big Data Analytics in Practice is open. I encourage all participants to participate actively in the interesting discussion. Hopefully, what we are doing today is useful for our progress in the future. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mrs. Professor Dr. Widyawati, SSI MSI, for the opening speech. Before we move to our main event, let us take some photo session first. To all participants, please, you may turn your own camera and then stand by in your screen. For Arif, you could stand by to take some screenshot of this slide. Okay, you could give us the sign or aba-aba,
Okay.
which slide you will take the screenshot.
1, 2, 3. Okay, once again. 1, 2, 3. Okay, once again, let's 1, 2, 3. Okay, done, Dila.
Okay, thank you, Arif, for helping us. And then after this, we could have some main event. And then before we move to our main event, I would like to remind all participants to please use the virtual background. The virtual background is attached on the chat box, and then you can use it. Or Mrs. Fatiha, you may see it again. So all the participants who has joined just now could use the virtual background. Okay. Thank you, everyone, who has already used the virtual background. This is Mrs. Fatiha already sent the virtual background again. And then I would like to remind to you, this webinar is discussing about big data analytics in practice. So everyone here, I know that you all are curious with the materials from Mr. Dr. Arif Kristanto. Okay, due to technical issues, Mr. Dr. Arif Kristanto needs some time to rejoin again because the signal. And then, yeah, lastly, I would like to remind again, you may use the virtual background again to respect all the speakers and moderators later. Okay, I already saw that there are 25 people already use the virtual background, and then the rest are still not using the virtual background, but is it okay? And then we will move to the main event, but before we move to the main event, I would like to introduce the moderator first. As we know that in the poster, the moderator is Mr. Dr. Budiwarsito, MSI. He is a lecturer in Diponegoro University. And then Mr. Dr. Budiwarsito already been spotlighted. Everyone can see Mr. Budiwarsito first. And then I would like to introduce him. The operator could share screen first.
Ya, halo Mbak Fadila. Stand to me.
Yeah. The operator could share screen for the CV of Mr. Budiwarsito. Okay. While we are waiting, I would like to tell you that Mr. Budiwarsito is a lecturer at Diponegoro University, and he also teaching me with data mining. And then, okay, CV screen is already. I would like to read first. Mr. Dr. Budiwarsito, SSI.MSI, just finished his education 1998 in Bachelor in Statistics at Gadjah Mada University, and just got his doctor degree in Mathematics at Gadjah Mada University in 2017. And then he is currently a head of Master Program of Information System, School of Postgraduate Studies, Diponegoro University, and he is also head of expertise Best Lecturer Group of Computational Statistics and Data Science, Department of Statistics at Diponegoro University. Also, his research interests are neural network, heuristic optimization, and time series modeling. So, Mr. Budi Warsito, hello, Mr. Budi Warsito. I would like to talk to you while we are waiting for Mr. Arif Gusnanto.
Oke, halo Mbak Fadila.
Okay.
Afternoon.
Hello, Mr. Budi Warsito.
Okay.
How is your day as a lecturer at Diponegoro University? Because I saw that you hold 2 roles as a head of master program, and then you also are head of expertise at Department of Statistics.
Okay, Mbak Fadila. I think today is like the day before. It's very busy, so because I have to manage into study program in statistics study program and Magister of Information System. So it's a double job for me, but it's great that this afternoon I can join in this general course, yes, with Dr. Arif Gusnanto. He called me just now that there is still a problem with the connection from Dr. Arif, so we still waiting for Dr. Arif about 5 minutes from now. Yeah, maybe from to wait the Dr. Arif, I can read the curriculum vitae from Dr. Arif, Fadila.
Okay, sure, Mr. Budi Warsito.
Okay, thank you, Mbak Fadila. The Honorable Dean of Faculty of Science Mathematics, Prof. Widawati, Dr. Tarno, Head of Department of Statistics, all of the distinguished participants, lecturer and student from Department of Statistics. This afternoon, we will listen to a lecture from our guest lecturer, an expert in a big data analytic from University of Leeds, Dr. Arif Gusnanto, in a visiting professor program held by Department of Statistics. As we know, that the visiting professor program is held regularly by Department of Statistics by inviting well-known speakers. And on this occasion, the expert we invite is Dr. Arif Gusnanto from University of Leeds. We know that he is an expert in the field of big data analytic. Okay, we can see in slide the curriculum vitae of Dr. Arif Gusnanto. He is a statistician whose research focus on the development of statistical methodology and inference in many areas, including those with high-dimensional data. Is a deputy project coordinator of IM for Future, a European Union-funded training network with a budget of 2.9 million euro. With 9 partners from 6 countries, with focus on the development of statistical methodology and analysis of genomic markers and biomarkers for aging. He is involved in many research collaboration and supervised at least 5 PhD students on many areas of statistical methods and application, and data science and analytics. He is also a member of the Royal Statistical Society. Dr. Arif Kusnanto earned Bachelor of Science and in Statistics from IPB University, and then PhD in Biostatistics from Karolinska Institute, Sweden, and then postdoctoral research statistician, Medical Research Council, Biostatistics Unit, UK. And then Dr. Arif Kusnanto is a lecturer and associate professor at Department of Statistics, University of Leeds, UK. He has many research projects in almost every year from 2011 until now, and the recent research grant is the period of 2019 until 2021 with the entitled Investigation of the Tumor Microenvironment in Early Onset Colorectal Cancers. He also has so many publications in the reputable international journal indexed by Scopus. I checked at the schema code that the international journal is indexed set by Scopus with the qualification Q1, Q2, Q3. All of the journal are reputable international journal. This is the curriculum vitae from Dr. Arif Kusnanto. Only one pic, but describe a very broad experience, I think. And I still contact with Pak Arif. Because of the problem of connection, he has to move from the office to home. About 5 minutes. Okay. Oke, Mbak Fadila.
Okay, thank you, Mr. Budi Warsito. While we are waiting, could we have some discussion first, Mr. Budi? Like,
Okay.
why are you interested in time series modeling, and then the rest.
Okay, I have been hello, can you hear me?
I can hear you, Mr. Budi Warsito.
Okay. I have been learned about time series modeling since for a long time ago, when I still a student like Mbak Fadila in bachelor degree. I have finished my degree with the final project with the theme of time series modeling, but still linear time series modeling. And then in master program and also in doctoral program, I also done my research in the field of time series modeling, but in the nonlinear areas with the neural network and optimization technique for obtaining the parameter of the nonlinear time series model, I think. So yeah, it's very interesting for me to learn about time series. Okay.
Great, Mr. Widiwarsito. And then I saw that you also interested in network.
Oh, okay.
Could you tell us what challenges that you face?
Okay, I see. I'm sorry. I see. Pak Arif has joined in this meeting. Yeah. Hello, Pak Arif. Pak Arif Kusnanto.
Iya, Pak Budi. Yes.
Oh, yeah. Yes. Alhamdulillah. Good afternoon, Pak Arif.
Afternoon, Pak Budi. Yeah.
Can all of us have been waiting for you to join in this.
Yeah, my apologies. It seems that the Zoom software in my computer has trouble. Yesterday, I used it to had a Zoom call for 4 hours. It was okay, so I don't know what's going on. So I'm using a different computer now. Yeah.
Oh, I see. Okay. Okay, Pak Arif, I have read your curriculum vitae, and all of us have been waiting for your presentation. And because now is 7 minutes from we have to start this presentation, so the time is yours to start your presentation. And Pak Arif, we have 90 minutes for presentation and question and answer. So you have about 60 minutes, but minus 5 minutes. Yeah, you have about 55 minutes to present your presentation, and then we will continue with the discussion. Okay, Pak Arif. Okay, time is yours.
Yeah. Thank you very much, Pak Budi. Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Ibu Dekan FMIPA Undip beserta jajarannya, Ketua Departemen Statistika beserta jajarannya, Civitas Akademika Undip, dan peserta sekalian, saya mohon maaf sekali, saya tidak tahu kenapa ini tadi ada problem dengan Zoom saya di komputer, padahal kemarin saya pakai seharian untuk Zoom meeting, nggak ada masalah. Kalau kata orang Irlandia, Murphy's Law itu nomor 1, things that can go wrong will go wrong. Jadi saya mohon maaf sekali lagi, izinkan saya share screen saya, boleh Pak Budi ya?
Oke.
Oke, ya, topik saya kali ini.
Sorry Pak Arif, we should use English for
English,
presentation.
okay.
Yeah,
Yes, that is fine. My today's topic of discussion is big data analytics in practice. So this is about me. I did my PhD in biostatistics from Karolinska Institute. I'm sure Pak Budi already mentioned about this, so I'm just going to go through this quickly. I did a postdoc in Cambridge Medical Research Council, and I've been in Leeds since 2007. So the purpose of this talk is to highlight big data analytics in the current industry 4.0 and some issues in the practice. Okay, so I'm going to discuss about this. My apologies in advance for those of you who followed my talks in the past year or so. There are some slides that I have already shown to some of you in a previous talk. But I can assure you there are going to be some slides, some new discussion points that I would like to share with you in this talk, okay? But before we go to the talk, I would like to ask for your help here. So if you go to socrative.com, yeah, with your phone, your mobile phone, or your HP. So open socrative.com in your web browser, yeah, and then go to click the login icon on the top right, and when it can choose student login, yeah. Not teacher login, but student login. Okay. Once you click the student login, and then when you are required to put the room name, just put my surname Gusnanto. Yeah. Okay. So you will arrive in a quiz. So I just want to have an idea the audience of today's talk. So please join the quiz. Okay. Use your mobile phone. Just join the quiz. Yeah. There are 61 of you, 62 of you are joining the quiz. So I'm going to give you 2 more minutes for you to join. Yeah. Just go to that socrative.com and then student login. And for the room name, I just put my name Gusnanto. Okay. So this is the first question. What is your background? Yeah. Whether you're a student in the undergraduate level or postgraduate level. Are you a researcher or a lecturer? Are you practitioner, professional, or others? Yeah. I give you 10 more seconds. Okay. So, right. 62% undergraduate student, 3% master student, 8% doctoral student. Okay, thank you. I think I already understand the audience at the moment. So majority of you are still an undergraduate. And this is the second question. Just stay in the quiz. Don't go anywhere. Just stay in the quiz. For those of you who said that you are in undergraduate, and in which year are you? Is it in the first year, second year, third year, or fourth and beyond 4? So only those of you who are in undergraduate study, okay? So I'll give you 10 more seconds, okay? Right. So majority of you, almost all of you, are in the second, third, and fourth year. Okay, great. Right. In the third question now, what is your study area or your work area? Is it statistics, mathematics, economics, business, finance, etc.? Computer science? Okay. Or you are part of a startup? Or others? Okay. I'll give you 5 more seconds. Right. 81% of you are in statistics, mathematics, while 5% in economics, business, finance, accounting, about 7% in computer science. Very good. I'm happy to have some participants from computer science. Thank you very much for your participation. This is the 4th question out of 6. Okay. So suppose you are generating a random number, yeah, random number, 100 random number from a normal distribution with a certain parameter, and the parameter is fixed. Let's say, for the sake of argument, you are generating from a standard normal distribution, normal 0, 1. Okay. So you first generate 100, and then you generate 100,000 after that. Okay. So you generate 100, and then you measure the mean. Yeah. And then you generate 100,000 random numbers from normal 0, 1 again, and then calculate the mean. Will the expectation of the mean decrease, the same, or increase? You know, comparing between 100 observation and 100,000 observation. Okay. Will the expectation of the mean decrease, remain the same, or will increase? Yeah, comparing between generation of 100 observation and a generation of 100,000 observations. Okay. Is it going to decrease, the same, or increase? I'm talking about the expected mean, yeah? Expected mean. Okay, I'll give you 5 more seconds. Yeah, right. Okay, so 70% of you got it right, which is it remains the same. Yeah, in terms of expected mean. Okay, 11%, 10% says it's going to decrease. I'm not talking about the standard error. I'm talking about the expected mean. Yeah? It should remain the same. Okay. Of course, the standard error is going to be different, but the expected mean will remain the same. Okay. The next question is the same setting, but now it's the variance. Will the variance decrease? The variance of the observation, okay? Not the variance of the mean, just the variance of the generated data. Is it going to decrease, the same, or increase? Okay. This is the variance of the observation, not the variance of the mean. Yeah, these are two different things. I'm talking about the variance of the observation. Whether the expected variance of the observation will decrease, remain the same, or will increase. Okay. I give you another 5 seconds. Okay, let's see the result. Yeah. 10% of you said it's going to decrease. 42% says it's going to remain the same. And 48% you say that the variation will increase. Right. The answer, the correct answer is that it will remain the same. The variance, the expected variance will remain the same. Yeah. Of course, the standard error of the variance will be different, but the variance itself, the variance of the observation will remain the same. Okay. You can check it in your software, whether R or SPSS, whatever. Yeah. It will remain the same, yeah, in terms of expectation. And now the last question, still the same setting. This is still the same setting. You're generating 100 and 100,000 observation afterwards. But what is the expected range of the the range of the data, which is the maximum minus the minimum? Will it remain? Will it decrease? Will it be the same, or will it increase? Yeah. Okay. I'll give you 5 more seconds. Is it going to decrease, the same, or increase? Okay. Okay, let me show you the result. Right. 6% of you say it will decrease. 62% of you will say it remains the same. 33% of you says it will increase. Now, the correct answer is that it will increase. Yeah? Yeah, it will increase. It will not be the same. When you have 100,000 observations, you can check it yourself in R, that if you have 100,000 observations, then the unusual observation, the extreme values will start to appear. Okay. which makes the range of the data increase because you have 100,000 observations. Okay, right. So thank you very much for participating in the quiz. Yeah, it's been very nice to see your participation. Okay, so let me go back to my talk. Don't worry, there is a reason why I asked you that quiz. Okay, there is a reason why I asked you that quiz. Okay, so I'll talk about the Industry 4.0 here. What happened is that in the 18th, 19th century, we had the first industrial revolution with the invention of steam engine. Okay, so mechanization started to take place to replace human and animal energy. And then in the beginning of the 20th century, we had electricity and mass production assembly line. That's the second industrial revolution. The third industrial revolution is the invention of computer in the 70s. Yeah, computer, so that robots started to be used and automation. That's the third industrial revolution. We are currently in the fourth industrial revolution, in which we have cyber physical system where gadgets and engines and all machines are interconnected through wireless technology. Yeah, in addition to the automation. So in this Industry 4.0, this is marked by the emergence of big data, yeah, and on everything. And in this big data, we need special handling. Yeah, it's just beyond Microsoft Excel. You can't use Microsoft Excel here. And then this is the lifeblood of Industry 4.0. And some say the big data is Industry 4.0. So I personally call this as the data revolution, okay, the Industry 4.0. So this is a slide from IBM that explains the 4 V's of big data. Basically, it is marked by first, the volume, the scale of the data is very big. Yeah, I don't know what's the biggest data that you have ever dealt with, but I personally have dealt with, in one analysis, okay, in one go, 600 gigabyte of data in one go, in a single analysis. This is 600 gigabyte of data that I analyze. It requires a special handling, of course. Yeah, your computer cannot handle, your personal computer cannot handle that. That's the volume of data. And then also it's marked by velocity. We have data that are streaming all the time, and this is where we get the data from a continuous reading of sensors or wireless devices. Okay. The third one is variety. So the data that we have, it can be in text, it can be in pictures, it can be in videos, it can be different types of data. So it is marked by variety, different forms of data. And lastly, veracity. Some of you may not be familiar with the concept of veracity, but basically is that the information contained in the data can be quite sparse. Sparse in the sense that that information can be thinly spread across so many data points that it requires a big analysis that combine all those informations to make a meaningful assessment on the topic at hand. Okay. And in business, it has been shown that those who are dealing with big data analytics will always win the competition. Okay, so if you see the table on the right, in 2008, the top 10 biggest company in the world are dominated by energy company. Okay, as you can see on the right. But if you go to the left table, just 10 years later, in the span of 10 years, now the technology company that handle big data that actually at the top 10 are the biggest company in the world now: Apple, Google, Microsoft, Amazon, Facebook, etc. Okay, so this shows that those who handle big data will win the competition. So some of the examples that I will show you come from this book called Big Data in Practice by Bernard Ma. I recommend you to read this. The first case in the book is about the Amazon. So I don't know whether you, the Amazon here is basically the Tokopedia or the Shopee outside Indonesia. So if you go to the US or in the Europe and Japan, Amazon is very big. Yeah. So they use predictive analytics. So for those of you who are in undergraduate, what does this, if you don't understand what predictive analytics, this is basically when you want to make prediction, okay, based on the data on predictors. Yeah, you can view linear regression, say. I don't know whether you have learned this. For those of you in the first year, linear regression is basically a model for prediction, but predictive analytics is much more than that. Okay, they use this to get full view of the consumers. If you think, what is the problem here? Well, here's the problem. The problem is that this online retailer, they have so many items on sale. When they have so many items on sale, they don't know what information that they need to put on the screen in front of the customer. You know, of course, they rely on so many products, okay, because they want to increase the probability of making sales. But the danger is this: there's going to be information overload, we call it. So, excuse me. When the information on the screen is overload, it's going to overwhelm you as a consumer. Okay, meaning that you may buy those items, but you will have a buyer's remorse later on. Yeah, in Indonesian we call it Anda menyesal kemudian hanya karena membeli cepat-cepat, buru-buru. Yeah. So they want to avoid this. They want to avoid buyer's remorse. So the solution is to perform a predictive analytics based on historical and customer data. So this is, for example, on my screen at that time when I open my Amazon page. You see, because I opened a book on big data in practice, so Amazon put forward, look, if you are interested in big data in practice, there are some other books on big data as well. So that's what the Amazon show on the screen. And also because I opened this Amazon page in spring here in the UK, these are the items that are sold elsewhere in the UK that happen to be a top selling during the spring. So as you can see, Amazon only wants to put forward the information on the screen that are relevant for that particular customer only. Okay, so if someone else accessing Amazon, then the screen on Amazon webpage of this person will be different to mine. Okay, this is how they perform the predictive analytics to make the information relevant in front of their screen. So this allows targeted marketing, And as a result, Amazon has become the largest online retailer in the US. Okay. Second case, this is about Walmart. Walmart is a supermarket in the US. In Indonesia, I don't know, it's probably Matahari, for example, or Hero, or yeah, these supermarket companies. So in their case, big data is used to drive supermarket performance, to sell a lot. So this is the largest company by revenue in 2016, yeah. And the problem that they have is that they are in direct competition with retailers and shops. Okay, they're competing on price, they're competing on customer service, and they're competing on convenience. They also have logistical problem because they handle thousands of products, if not tens of thousands of products at the same time from thousands of suppliers. So how the logistic is going to be handled? This is a problem. Yeah, we think getting the right product at the right time to the right people to the right store, etc. Okay, so the data that they use is a transactional data. Okay, 200 billion rows. Yeah, 200 miliar baris. Yeah, that's how big the data, and that is just from the last few weeks. Yeah, it's not even from the whole year. It's just for the last few weeks. Yeah, 200 different data sources. Yeah, including meteorological data, economic data, telecoms data, social media data. Yeah, for example, they want to know what are people tweeting in a certain area, for example. So when people are tweeting about that keyword, that Walmart will do their best to provide that product in their store at the right time. It's that advanced in terms of the prediction. Okay, so as a result, the Walmart pharmacies, basically inside the Walmart, they have a pharmacy. So it makes them more efficient. So in terms of staff scheduling, they know what's the busiest time of the day, of the month, of the year. They know exactly, so they can put staffing. And secondly, they manage supply chain very well, optimize the routes between points, yeah, get the transportation cost down, because they just make the product at the right time to the right place. Okay, they also optimize product assortment, what are selling or about to sell. So they want to avoid products that are not selling to maximize the space in the shop, in their supermarket. They also personalize shopping experience. They can give a certain discount to a certain customer, you see. That's the best thing about this. So for example, if I buy a shirt, but I didn't buy the trousers, supermarket can send me a discount code. If you buy trousers, you will get this discount. They know if I buy this shirt, but I haven't bought the trousers, that I will need trousers soon. Okay, and then fast troubleshooting, so they can monitor transaction in real time. So if there is a problem in the transaction, they can solve it quickly within minutes rather than weeks. Yeah. In the third case, this is about General Electric. So you may not heard about this, but you have used their product to some extent. Yeah. They produce a lot of high-tech product, plane engine, yeah, and healthcare products, yeah. So the problem here is that how to keep the machinery and systems running efficiently, yeah. For example, the plane engine. Of course, when the plane is on the air, you want to make sure that the engine is performing optimally, okay? For obvious reason, because if it's not optimal, then it's not going to get you where you want to go, okay? So and it has an implication, because if it's not running optimal, it will increase the running cost, and of course safety implication, yeah, downtime as well. So they want to make sure that the engines, the machines, are running efficiently and optimally. So they put sensors on their engines and in their machines, and these sensors collect data on everything, on the performance of each parts of the engines. Yeah, so they collect this data and they analyze this data. Yeah, even during the flight. So you're not feeling it, but if you take a flight using aeroplane, I don't know, from Semarang to Jakarta, for example, then the plane that you are using is actually collecting data as the plane flies from Semarang to Jakarta on the engine performance every few seconds. Yeah, and approximately 500 gigabyte of data, yeah, per flight. Can you imagine? Is collected. Yeah, and as a result, because they can make sure that the engine is running smoothly and optimally, they are saving their customers millions of dollars, yeah, from reduction in downtime per year. Yeah, so it saves money for their customer because analyzing this big data. Lastly, this is the fourth case, Netflix. I don't know whether you are familiar with Netflix. In Indonesia, it's probably video or something like that. Yeah. So it's basically content platform and production company. So it's delivering movies and TV shows online streaming. So the problem that they are facing is how to increase the watching time of their customer. So to increase the watching time, they want to make prediction what the customers would enjoy watching. What would the customers enjoy watching? That they want to make prediction on your pattern of watching. What do you like? Then the Netflix will try their best to customize the suggestion for your watching plan. Okay. So why they want to increase watching time? Well, if you increase watching time of the customer, then it will give a sense of value for money. I don't know whether you are familiar with this concept, value for money, meaning that you feel that the money that you spend in subscription is actually worth it, if you know what I mean. Yeah. But if you have value for money, then you're satisfied as a customer. When you're satisfied, then you continue your subscription and probably tell others about your experience. Yeah. So it's increasing customer base. So the data that they use is a detailed use of apps or web access from their customer. When the app is used, which shows or which film watch, how many times, when, whether there is buffering or not, whether you stop at certain point or not during the movie, whether you finish the movie in one go or 2 or 3 different times, etc. What's the rating that you give to this movie, etc. I've seen the data myself because I examine a master student who analyzed data from Netflix. Oh, it has a complete data on your pattern. Okay, it has really a complete data, a big data on the pattern of your watching. So, for example, they know customer X on this particular date at this particular time, watching this particular movie, starting from this point, ending at this point, and this customer stopped the movie at a certain point, etc., etc. So it has a complete picture on your watching experience. So they want to make prediction on what the customers will enjoy. Yeah, for those of you in master degree on PhD degree, You are familiar probably with the hidden Markov model. You are probably familiar with the random forest. These are the types of algorithm that Netflix use to make prediction, yeah, on what the customers will enjoy. And they also perform segmentation and personalization. If I open my Netflix app in my phone, the screen, the show that is appearing on my Netflix app will be different than someone else, because Netflix is personalizing the suggestion, okay? And because of this, they have micro genres, more than 80,000. So for us, probably we can't say that, oh, this is action movie, or this is horror movie. No, for Netflix, that is not a genre. For them, they know, oh, this is a horror movie with a male character as the main character, and it involves violence or killing. Or this is horror movie with a female main character with family setting and no killing. So these are the type of genres that Netflix use, and it's part of their predictive analytics, okay? And as a result, and this is the number of subscribers that the Netflix has from 2001, almost nothing. And as January this year, they have 205 million customer subscribers, okay? So imagine here in 2008, 9, and 10, when there is economic crisis, their customer number still keep increasing. So you know that even with big data analytics, you can avoid a shock from economic crisis for a service company like Netflix. Okay, so this is a very good point. So some important notes on the practice of big data analytics here is that first, the principles transfer to small businesses as well. If you think that this is only for big businesses, you are wrong. Okay, I can give you some examples in which in small businesses they are actually working. Okay, and there is a reason for this. I will come to this, okay, in the next few slides. Number two, big data analytics aims to solve a problem, but not all problems are solvable with big data analytics. Yeah, if the problem is in management, for example, then the big data analytics can only help, but it's not going to solve. You know, if the CEO is not good in his job or her job, yeah, so to solve the problem is to replace him. Okay. So here the identification of problem is critical. Yeah, we as Indonesian generally we are weak in problem identification. Okay, so this is a skill that we need to harness to sharpen. Okay, so if you're more experienced, the better you are in identifying problem. So you need to work on this as a skill. Okay, problem identification is a very, very critical skill. Okay. Thirdly, the key is to follow the data. Yeah. So everything is data, and customer preference, need, aspiration, ideas, or thinking. Online transportation service, for example. Yeah. Your desire to take an object, for example. Okay, it's not a data for some of you, but for me it's data. Well, because when you're thinking, oh, I want to take object, it's because why I call it a data, because in your mind you are already thinking that I want to go from A to B using object. It should start from here at this time. It should arrive at that place by a certain time. So all this information are actually data in your mind. And Gojek app or Grab app basically translating that information into something that is actionable. Yeah, something that can be followed up. Okay. The next point is about ICT infrastructure system, and this is a challenge in Indonesia. Space handling of data, hardware and software, and it should be scalable. Okay, so in a business, for example, scalable means if the business is small, then the ICT infrastructure should be appropriate, but when the business increases, it should be scalable. You should be able to increase the capability of the big data analytics to match your business growth. Okay. And lastly, and this is important, is about statistical thinking. Yeah. So whether you are a business person, you are a computer scientist, whether you are, I don't know, from a different background than statistics, you still need statistical thinking. Okay. You may not understand the theory behind it, but it is important that you understand the thinking, yeah, statistical thinking about the analytical methods, and why statistical thinking is important, because the big data analytics will produce result, and you need to interpret the result in the end. Okay, so that is important. You need to interpret this in the end, because when you interpret this, and then it will become insight and action. And this is the last point that I want to discuss with you. Some people say that big data is big hype. Okay, they say, big data is just nothing more than small data. Okay, there's no difference with small data. Big data is just, I don't know, in Indonesian, it's just gembar-gembor. Yeah, it's just it's just jargons. Okay, jargons. It's just istilah. Okay, so they say that it's just a upscale of small data analytics. Yeah, they argue that the analytical methods remain similar. For example, if you perform a t-test on 10 observations, remains the same test on 10,000 observations, for example. Yeah, and these people, they tend to cite a Google case in predicting the next hotspot of flu. I don't know whether you follow this issue in the past, that Google claimed to be able to make good prediction with big data that they have on the search engine. Yeah, but they forgot to hire statistician. Yeah, that's the problem. They are full of computer scientists only. No disrespect to computer science, no. But they need to collaborate with statisticians to interpret how they should handle the data. They forgot to hire statistician in that case, because in statistics, there is something we call causal inference. Okay. Had they known about causal inference, they wouldn't do this. Okay. So my experience suggests that there may be some element of truth there. Yeah. If you calculate mean for 10 observation, and if you have 100,000 observation, you calculate the mean, it's still the same mean in terms of method. Okay. So to some extent, yes. Okay. Big data is equal to quote unquote small data in terms of methods. But that's only for simple statistics, you see. Okay. From data engineering point of view, big data is at different level than small data. Yeah, in terms of storage, handling, and processing. Yeah. If you think analyzing 600 gigabyte of data, like what I did, is the same as handling a 60 kilobyte of data, you are wrong. Okay. From just copy pasting the data from my computer to high power server, since you click copy and paste, it takes 1 day, you know, 1 day, just copy and paste, let alone analyzing it. Just copying the data itself between my external hard drive to high power computing server, it takes the whole day just to make the copy. Okay, that's a simple example that big data is at different level. Now, I would argue this, that when we say big data, big hype, I said, no, it's not a big hype. Big data is something different. My argument is this: the emphasis of big data analytics is in the word analytics, not big data. Okay, that's the key. Yeah, that's why it's also working for small business, because the emphasis in the analytics, not in the word big data alone. Okay, so big data analytics is a solution, so it requires a problem to solve. Okay, so identification the problem is critical. So the analytical methods for big data may be the same as small data only if it is appropriate. But many times it doesn't. That's the thing. Many times the method that you apply for small data is not appropriate for big data. It's the appropriateness that matters. Okay, because at the end you need to interpret the result, and it needs to be with the right method. Okay, so when you have big data, unusual observations around the extremes will start showing up. Okay, that's why I had that quiz before. Yeah, you can check it yourself using R. The mean and variance will be consistent, but the observed range will increase. Okay, here's an example. If you survey 100 people in Semarang, I can guess that this 100 people, probably only 2 or 3 people that is seriously ill. Yeah, maybe they have a problem with their lungs or whatever. But if you survey 100,000 people in Semarang, you will get observations that shows extreme cases. Those who have a severe cancer, those who have a severe genetic disorder, those who have severe cases of disease, etc., will show up in your data. Okay, that's why in clinical trials, they have phase 1, phase 2, and phase 3 is precisely because of this. They want to control any potential extreme side effects. Okay. Secondly, when you have big data, dependencies between observations will occur. Yeah, be it family connection or spatial dependencies or other underlying unobserved factors. Yeah, for example, if you want to survey Semarang with, I don't know, 100 participants, yeah, observations in Semarang, 100 people you survey in Semarang, most probably these 100 people are not connected to each other. They're independent in a way. But if you survey 1 million people in Semarang, including in Banyumani and certain area around there, 1 million, you will have your uncle, your cousins, your aunts, your family member, or those who share the same, those who come from the same household, those who come from the same kelurahan, from the same kecamatan, from the same complex, etc., who share a certain characteristics. Okay, which mean dependencies will start to appear. So when the test of method requires independent observations, then this can be a problem. So you can't just scale up small data analytics with the big data. You need to be aware of this problem. Okay. Next point, when you have more variables, high dimensional data, dependencies between variables will occur. Okay. If you have, I don't know, in a survey, you have measured 10 different variables from one respondent, for example. 10 different variables. these 10 variables might be independent. I don't know, might be, or can be considered independent. But if you are measuring 200 different measures from one respondent, then you will bound to get some variables that are correlated. Why? Well, because we don't live in isolation, you see. We live together with other people. So for those group of people who have a certain characteristic in one variable, they tend to have a certain characteristic on the other variables. Those of you who are working in economic survey, you know this very well, yeah. That the data, or in a clinical variable, that the data is going to be correlated, yeah. So given this, you have two options, whether you ignore or to embrace them. Embrace means you take into account, you actually deal with the problem. If you ignore them, then you may end up with less optimal prediction and difficult interpretation of the result, because you are ignoring the real characteristics of the data, yeah. Even for the methods usually used for big data, yeah. For example, I have a current research with my collaborators in Universitas Negeri Padang on random forest for big data, yeah. It turned out to be that if you ignore the correlation between variables, you will end up with less optimal prediction, yeah. And people in business who deal with big data, they use random forest a lot for prediction. So technically speaking, if they ignore the correlation between variables, they are actually less optimal, okay. If you embrace them, then you may have a problem in the model selection or variable selection, yeah. It also end up with less optimal prediction. So what's the solution? Well, you need to address the big data challenge with appropriate methods to address the challenges, okay? Be it complex modeling, taking into account heterogeneity in the data. If the data shows some hierarchical structure, then you need to respect that from your data, yeah? So small data analytics is just too simplistic to deal with this problem. Right, and this is the last slide, I think. So with the current developments in business, research, and other areas, okay, so big data analytics is needed more than ever, yeah. Some success stories, but challenges remain. We have seen some success stories, but also we still have some challenges, okay. So there are still some areas. So if some researchers or Civitas Academica in Undip wish to collaborate on this big data analytics with me, I'm more than happy, because there are some more challenges still remain to be solved in this big data analytics, yeah. Thirdly, big data is not big hype, yeah. Analytics is the main thing, okay. I think that's the most important thing. I'm not saying big data is not important. It is important, as I said, but the emphasis, yeah, is in the word analytics, because that's the critical bit, yeah. So a key to success in practice is how to deal with the characteristics of the big data. So I hope that is clear from what we discussed. So thank you for your attention. I'm now stop sharing my screen, Pak Budi.
Okay, thank you very much, Dr. Arief Kusnanto. Great presentation from Dr. Arief Kusnanto. And we talk about big data in practice in various fields. I think I have an interesting phrase from Dr. Arief Kusnanto that a big data analytic aims to solve a problem. Yeah. Not all problems are solvable with a big data analytics, so identification of problem is critical. So we need a statistical thinking, I think, to analyze the big data. And for me, one of the most interesting is a nice quiz, Pak Arif. Yeah. Okay.
Thank you.
Okay. I want to give chance for the participants who want to make a direct question by raise your hand, or you can also drop your question in the chat box. I see. There are a lot of questions in the chat box. The first chance question from Rahmat Sagar from IPB University. Is big data analytic a science or a technology? Please, Dr. Arif.
Yeah. Yes. The thing is, basically, big data analytics is a science, but it's not going to be materialized without the technology. That's the thing. So as a scientist myself, I deal with big data analytics and the technology itself. Yeah. So I hope that answers the question.
Okay. Okay. The second question from Gina Nabila. How many volume of data that can be called as a big data? If there's some 10,000 cells of data, it can be called a big data or not? Thank you.
Well, yeah, there is no straightforward or simple cut-off for what we call big data. No, it's not like if I say 10,000 rows is big data and 9,999 rows is not big data. It's not like that. Yeah. So what we can say is that when, for example, your variables is in the order of thousands, yeah, it can be considered big data. Okay, your variables. If your observations are, I don't know, in hundreds of thousands, yeah, or at least 50,000, is probably can be considered big data. But that is a loose definition. It's not really a straight, like a strict cut off for what we call a big data. When it becomes a challenge for you to do things in a simple way, that becomes a big data. Okay, I think that's probably a better way of describing it.
Okay, there's no fixed size from.
No, there is no fixed size on that. Yeah.
Okay. We continue to the third question from Chitra Amira. What are the difficulties or challenges of analyzing big data?
Yeah, to some extent, I already explained this in the slides, but I can say from my personal experience that the challenge is actually both from technological point of view, the data handling, storage, computational aspect, which is the computer science side of things, and also modeling. So just to give you an idea, the type of challenges that I face every day. First is the storage of the data. Okay, I'm dealing with hundreds of gigabytes of data at one time. So the storage is key. Number two is the modeling. The statistical model or statistical methods to deal with this type of data, because there are some characteristics of the data that is not usual for small data, like I mentioned. Okay. Number three is that when you analyze it in the server, okay, you have to use multi-core environment. Okay, so I have to learn about multi-core processing in computing. So if I run the data on a single core, yeah, it will take me forever to analyze that data. So you need to have multi-core computing computational methods, yeah, I usually run on 40 cores, which is more manageable to run at one go. The analysis that I do to make sense of the data. So I guess those are three challenges that I can share with you from my day-to-day experience.
Okay, thank you, Pak Arif. I see the raised hand from Fadila Atansa. Would you like to make a direct question? Pak Fadila?
Sure.
Okay, please.
Yeah. Okay. Good evening, Mr. Arif Gustanto in Indonesia. And I would like to ask, what do you think about cryptocurrency right now? As we know that cryptocurrency adopts blockchain technology. And what do you think big data impacts the cryptocurrency? Thank you.
Right. I'm not following the development of cryptocurrency that much. Okay. I learn only from newspaper. So I'm not able to comment on the details of that. But what I can say is this. The idea of cryptocurrency is trying to solve a computational problem for the currency to be traded. Okay, so that itself, yeah, is already a big data. Okay, because there are several 128 layers of problems to solve, and it requires high performance computer to get the cryptocurrency done. So it's cryptocurrency itself requires big computational power. Yeah. About the data, I'm not sure because I haven't seen the data myself on cryptocurrency. But what I can say is that in itself is a big data. Yeah.
Thank you, Mr. Arif Gustanto.
Okay, enough, Mbak Fadila?
Enough, Mr. Budi.
Okay. The next question is from Diandra. Good evening, Mr. Arif Kusnanto. I would like to ask, in Indonesia, we just adopt this kind of data technology, which is still new to us. What do you think about data technology data tech startups that are currently growing up in the world? Are they helpful to citizens? As we know that we have low data literacy in Indonesia, and they are supposed to help us. Thank you.
The thing is with the startups is that they are challenged to produce the big data analytics in terms of results that are translatable or interpretable by the public. Okay. So here's the thing. When you use the Gojek or Grab app or any app or Tokopedia, for example, what you see on the screen is not the data itself, but is the result of the data analytics. Okay, because you know the crunching bit, we call it in English, the data crunching bit is actually done. The analytics of the data is done behind the screen, we call it. Yeah. So in my opinion, in the next few years, this will become big in Indonesia. Those who are dealing with startups, they already know that they need to embrace the big data analytics, because that's how they can survive. Yeah. You name it, any startup that you can name, behind them, behind the app, there are data analytics going on. So I'm quite confident that the prospect of big data analytics will still be positive in Indonesia. And I mentioned this to Pak Budi yesterday. In the UK, for example, the UK needs about 7,000, 8,000 data scientists, statisticians every year, but the UK only produce 3,000 graduates. Okay, so there's always a lack of people with certain skills.
Yes.
Now, when in Indonesia, when the startup technology, startup economy, or this creative economy will get traction in the next few years after this pandemic crisis. Don't worry, this pandemic crisis is a learning curve for a lot of startups. You see, after this pandemic, maybe next year, 2022 or 2023, you will see a lot of booming of Indonesian startup. Yeah, you will see yourself. Yeah, and this is going to be, for those of you who will graduate this year or next year, it's a good news for you. Yeah, it's good news for you. Yeah, okay.
Yes.
So for you, those of you graduate this year or next year, it's good news for you, because in 2022 and 2023, a lot of startups going to hire a lot of statistician, data scientists, etc. So it's a good positive development. Yeah.
Okay. It's good a big opportunity for statistical students. Yeah. To be data scientists. Yeah. But we should have learn more about big data and also data science. Okay.
Yes.
Okay. We go to the next question from Faisal Fikri. What kind of insight should we extract from a big data analytic, regardless of its number of size?
Yes. So the insight depends on the context of the problem. Okay. So that's why you need to identify what the problem is. Okay. You don't go and see a data and say, okay, let me analyze the data. That's it. It's not going to help you. Okay. When you see a data, or even if you do not see any data, you see what the problem is first. Because it is possible that the data that you need is going to be generated first. So it's the problem that drives the data, actually. Yeah. So when you understand what the problem is, and then you see what the data look like relevant to that problem, and then you analyze, then the insight that you want to get from that analysis is supposed to be linked to the context of the problem. Yeah. So I think that's why problem identification is critical. Yeah. So we say in English here that a well-defined problem is half solved. I don't know whether it's clear for you. So a well-defined problem, jadi problem that is defined properly is basically half solved. Yeah, imagine if you have a car, if you're driving a car and then the car broke down on the side of the street. Okay, the car broke down. If you don't know where the problem is, it gives you headache, isn't it? What's the problem with this car? But when you know where the problem is, yeah, then the problem is half solved. If the problem is you run out of benzene, it's half solved already. Okay, all I need to do is just go to the gas station and then fill up the tank. Okay, so I think that's the key for the insight. Thank you.
Mr. Budi, your mic mute.
I'm sorry, still mute. Yeah. Okay, the next question is from Yasmin. Thank you very much for presenting your material today, sir. Permission to ask you, what do you think the function of big data to stop COVID-19? And how long will COVID-19 stop if we use big data to predict it?
Well, it's actually a big data problem. I don't know whether you realize this, but the COVID-19 is a big data problem. Okay, first, in terms of the vaccination, yeah, the UK government analyzed a lot of big data on who is, they have a big data for all patients, all population of England and Scotland and Wales, okay? So they know if someone got ill, why they got ill because of COVID. And then that's from public health side. From vaccine development side, a lot of experiments done and a lot of big data to generate, to create the vaccine. From surveillance point of view, the UK government analyzed thousands of genomes on virus. Okay, this I'm talking about terabytes of data every week on genomes. Yeah, the UK produced half of the world genomes on the virus for genomic surveillance. So they know if a virus is mutating, they know in which sites the mutation goes. And then lastly, from track and trace, yeah. So everybody download an app where they can show whether they get symptoms of COVID or not. And then there is behind that is a big data, just like Gojek, to track which people in which area start to develop a lot of symptoms, in which the government will perform a local lockdown or a restriction. Okay, so it's pretty much a big data, and without this big data, the COVID will not be able to be contained as we did now. I mean, without the big data, the pandemic could have been much worse than what we are experiencing at the moment. Yeah.
Okay, thank you, Dr. Arif. The next question is from Rahmat Sagara, but this is the second question. So because there are still a lot of questions for another participant, I will give a chance to from Muhammad Hilmi Rozan. Thank you for the opportunity. I am Muhammad Hilmi Rozan from Statistik Undip. Permission to ask, what kind of software used for analyzing and saving the big data? I have heard that to resolve the big data is using Hadoop. How does Hadoop work in dealing with big data?
Yes, Hadoop has been one of the best common software for analyzing big data. That's true. Yeah, but for those who deal with the modeling side of things, rather than in terms of analysis, it's just running it. Yeah, Hadoop is very good. But in terms of modeling, some people still use Python and R. Python is actually more common for the analysis of big data because they are more efficient. R is less popular, but it's popular among statisticians because of the libraries, complete libraries that they have. So I personally use R. I'm not using Python. But in R, I'm using multi-core environment to analyze, to speed up things. Yeah, Python is very good in terms of multi-core and memory management. Yeah, so my suggestion is that when it comes to big data, just use any software that you consider to be appropriate or practical. Okay, every software has its own advantages, disadvantages. Yeah, so I'm not going to start a war by declaring which software is better.
Okay. no software or something like that, that best for all, I think.
Yeah.
Okay, the next question from Debbie from Unsrat Manado. Regarding the big data phenomenon, what do you suggest for the Department of Mathematics or Statistics to equip our student?
Yeah. I still owe Mbak Dewi a draft. I'm writing it. Okay, Mbak Dewi. Debbie, yeah. So for students, and this is my personal experience, is that in School of Mathematics in Leeds, yeah, in School of Mathematics, students are exposed to two different software, which is first is Python, second is R. So when the students graduate, students are able or familiar with those two software, Python and R. Okay. Now, in the School of Mathematics, we have some modules or mata kuliah in Indonesia that are considered project, what we call project modules, which the students have to do for the whole year, so across 2 different semesters. Okay. So in these modules, there are several projects that are being offered to the students, and some of them are in big data analytics, and usually it's quite popular. Yeah. So for teaching or equipping the students with big data analytics experience, I strongly recommend that for some projects, students are offered the possibility to run a project with the big data analytics and equipped with at least one of Python or R, but it will be great to have both Python and R. Yeah. So I think that's only my suggestion.
Okay, thank you, Dr. Arif. Python or R, yeah. Okay, the next, and I think the last question that can be answered by directly by Pak Arif from Resnandar Kemensos. Long question, but Pak Arif have only 3 minutes to answer it. Indonesia should be a great country with the big data analytics. We have big data from Susnas, a unified database, and poverty from BPS, managed by Musano, citizenship data from Dukcapil, and etc. They should be collaborate each other to make this country great again. Planning, policy making, poverty alleviation program, and some other, especially in this SDGs. And then in my part, why the government never noticed about this data potential? Is it about human resources, technology, or what? We have Prof. Arif Kusnanto as one of the big data analytic expertise. Am I right? Yes. What do you think, Professor? Thanks in advance.
Right. So I'm not familiar with the internal government database, but what I can guess at the moment is that these databases are not yet linked. Okay, not yet linked. So it's the linkage between this database that is critical. I have not seen a unified system that the government currently is operating on. I'm sure they will be thinking about integrating this different database in the future, but at the moment, I haven't seen an integrated one. The reason I'm not sure, maybe because of policy or because of regulatory constraints, yeah, or with regulation, etc. But what I can say, ideally, what should happen is that you see, like in Europe, like in Sweden, for example. Sweden is a good example. I used to live in Sweden for 4 years. That's why I can say about this. Is that when a baby is born, in hospital, before this baby is given name, the baby is already given a tax number. Yeah. So when the baby is born, before even we give the baby a name, we already know the baby's tax number. And this tax number will be carried with you for the rest of your life until you die. Okay. So this tax number is how the government of Sweden operates from, I don't know, banking, getting salary, whatever, doing this, doing that, access to the library, access to this, access to that. They will ask you for your tax number. You cannot do corruption as well, because the tax number is linked to your employer, to your bank, to your any other accounts, or all are synchronized. This tax number allows the government to identify for each person whether they should pay tax or they should be given tax, if you know what I mean. Yeah, because if people are unemployed for some reason, they are given money by the government, actually. Yeah. So I hope in the near future that the databases will be linked, and we can see a better service to the people because of the linkage of the data. In the UK, it has been shown that the linkage of the data is part of the main success of the UK government in containing the spread of the virus, the COVID-19, because they have a link of data between the public health, the GP records, the doctor's record are all linked in a single database with the government record. So I hope that, that explains, yeah.
Okay, thank you very much, Dr. Arif. There are still some questions, but I think the time is up because in Semarang it is almost time less than 10 minutes to break the fast. I think.
Yes, yes.
So we have
my apologies for the delay earlier.
Okay. Okay.
Technological glitch.
Maybe I give you 1 minute for closing statement from Dr. Arif Kusnanto.
Thank you very much, Pak Budi. My apologies for the delay earlier. I do not have any further comments, but I personally am happy to collaborate and discuss if you have some questions or potential topics to offer to master students or PhD students, and to discuss in research, for example. So just let me know in the email, and then I'm happy to discuss with you. My thank you to Universitas Diponegoro, Departemen Statistika, and the Civitas Academica, Pak Tarno, Ibu Dekan, dan Pak Budi for inviting me. Thank you very much. Yeah.
Okay, thank you very much, Dr. Arif Kusnanto. Okay, I think the time is up for us to listen the lecture from our great lecture in this evening. Dr. Arif Kusnanto. I am the moderator. Apologies if there is a mistake in guiding the program, and I give back the time to the Master of Ceremony. Okay, please, Mbak Fadila.
Thank you, Mr. Budi Warsito, and thank you, Mr. Arif Kusnanto. And then we almost finished this event, but before we close the event, I would like to give some appreciation for Mr. Arif Kusnanto and Mr. Budi Warsito. And for Ms. Fatiha, could you share screen for the e-certificate? Okay, and this is for Dr. Budi Warsito. We would like to appreciate your moderating just now. Thank you so much for moderating this webinar. And then next, we would like to give appreciation also for Mr. Arif Kusnanto. Thank you for the information and knowledge which have been given to us. May it be useful for us. And we also wish the best of luck ahead for both of you. Thank you so much. And then finally, we also get to the last session in this event, that is closing session. But before we close, I would like to remind all participants to turn on the camera and we take a picture, some picture again. So Arif, could you tell us the signs or aba-aba if you want to take the screenshot?
Okay. Remind to all participants, please on your camera. I will take a picture on 1, 2, 3. Okay. Once again, 1, 2, 3. Okay, last time. 1, 2, 3. Okay, thank you, Dila. It's done.
Okay, thank you, Mr. Arif. And then we finish this session. As the Master of Ceremony, I would like to express my gratitude to all of us that attended today's webinar. Thank you for all the webinar participants. Thank you for all lecturers of Department of Statistics and Mr. Arif Kusnanto. May what we had conducted today will be useful for us. If in guiding in this webinar, I made mistakes, I do apologize. And ladies and gentlemen, thank you for your actively participating in this webinar today, and may we meet in another webinar. Wassalamualaikum warahmatullahi wabarakatuh. Thank you so much. Happy breakfast, everyone.
Thank you, Pak Arif.
Thank you, Pak Arif.
Thank you, terima kasih. Assalamualaikum.
Arif.
Selamat berbuka puasa. Mohon maaf
Ya,
tadi
sama-sama.
terlambat.
Sama-sama Pak Arif. Ya. Kapan-kapan bisa ketemu lagi. Offline ya Pak Arif. Ini pas buka puasa ini.
Saya masih 9 jam lagi.
Oh, iya. 9 jam ya.
Iya.
Jadi nanti balik ke kampus lagi Pak Arif.
Iya, kayaknya balik ke kampus lagi, tapi nggak tahu nih. Kayaknya di rumah juga bisa, saya nggak tahu nih Zoom-nya. Padahal ya kemarin seharian saya Zoom-an itu. Bingung saya.
Iya. Kemarin kan testing juga lancar juga ya.
Iya, enggak, setelah kita testing itu kan saya ada meeting lain. Lah ya itu meeting terus sampai sore itu masih pakai Zoom terus itu saya. Aduh. Dugaan saya itu kayaknya ada firewall atau setting yang nggak bener kan, kadang-kadang suka ada ini baru atau apa gitu yang update atau apa yang kita nggak sadar, dia membuat restriksi di firewall sehingga nggak bisa masuk ke seberang sana.
Iya.
Iya. Makasih banyak.
Ya,
Pak
ya,
Budi
terima kasih
ya.
loh. Arif, ya.
Sama-sama Pak Budi. Pak Tarno, matur nuwun, matur sembah nuwun. Yeah.
Kalau pas pulang Jogja kabar-kabar Pak Arif.
Insya Allah ya, insya Allah saya kabari. Monggo, saya pamit.
Matur nuwun.
Assalamualaikum.
Salam.
Mbak Fatihah.
Belum, Pak.
Ya, monggo kalau mau di end meeting.
Ya, Pak. Selamat berbuka puasa semuanya.
Selamat berbuka puasa, Mbak.
Cheers.
Semuanya.
Saya end dulu ya meetingnya. Terima kasih.
Terima kasih semuanya.
Terima kasih. Dadah.